Besides just grouping together numbers, which may or may not be related to each other, we can use arrays to store data that's based on the relationship of a mathematical function. This could be all sorts of different things. We could create an array with the name of y, that's a function of x, or velocity, that's a function of time, or force, that's a function of mass. You name it. If it's based on the relationship of a mathematical function, chances are we can store it in an array. Let's take a closer look. Let's have a look at a couple examples where we use arrays to store the result of mathematical functions. We'll start out with a simple function, an equation that can be used to create a line, where this is the linear relationship between two variables. The common way to write this function is y equals m times x plus b. In this function, the variables m and b are constants. M represents the slope, and b represents the y-intercept. Then we have the variable x, where we're going to look at and plug in different values for x, a range of x, and see what is the result in y for each value of x. In this function, the y variable is called the dependent variable. The x is called the independent variable. Y depends on x. So let's go ahead and plug in some values. Assign here m to have the value of 2, and b to have the value of 1. Now we can use that relationship, plug in different values of x to create an array here of y. So we're going to use the square brackets for our array. Let's put in some values here. How about m times 1 plus b. I'm going to go ahead and copy this so I can use it over and over again. I'm going to put in here 2, 3, just substituting in a different value for x. And what we're going to do is then assign each result here to an element of an array that we eventually store in y. So we can see that as we plug in different values for x, we get an array with 3, 5, 7, and 9. However, we don't actually have to use just positive numbers. To also illustrate this, let me add in a few more elements here at the beginning using some negative numbers. So how about here we've got -2, we'll do -1, and then 0. So this is a longer array, more elements that include negative values for x and positive values for x. This is a pretty inefficient way to create the array, but I'm using it as an example to help illustrate or visualize exactly what's going on here in this array. So now we've got these values of our mathematical function assigned to y. Next, let's look at a different mathematical function. So instead of just a line, let's use the sine function. So let's create an array here, S, that's going to store the elements of an array where we use the sine function. We go through one cycle of our sine function. So let's do sine here of 0 to begin with. Then we'll do sine of, how about pi divided by 4? And then we'll do sine of pi divided by 2. Sine of 3 times pi divided by 4. I'll go ahead and copy this to speed up the process. Go through 4 pi divided by 4, 5 pi divided by 4, 6 pi divided by 4, 7 pi. We'll get all the way back around here to 8 pi divided by 4, or in other words, 2 pi, which is the end of our cycle. So now I can close off that array, and we can look at, we're creating a variable s that's a function of sine. These are the results, and even for good measure, why don't I go ahead and just plot s? We can look at visualizing the result in this array. So we've got one cycle now of our sine function for each element, starting at element 1, 2, 3, all the way up to 9, right? We're plugging in the values here of 0, 0.7071, 1, and so on. So here are several examples of how we could use arrays to store the result of mathematical functions. Now we're ready to look at, with audio signals, how we can use an audio signal that's a function of amplitude versus time and store that in an array.